Assalamu alaikum everyone. In this video, we will be talking about the expansion of binomial series or infinite binomial series. This is a formula that is used to expand finite series where you have integer power, and if you have an integer power, then you will get finite number of terms. Like if you have a power 10, then you will have 11 terms in that particular series of expansion. This is basically covered in AS Math B1 or even in O-level Add Math. Right now, we will be talking about another formula for the expansion of binomial series where you can have non-integer powers or you can also have negative powers. In that case, if you will expand a series, you do not get a finite number of terms, you actually get an infinite number of terms. So you can keep on expanding it and you would be asked to expand it for up to a specific number of terms. In case if you are wondering where the formula comes from, you can obviously do some research on Maclaurin's expansion and you would be able to identify how this is done. Or maybe I can make another video regarding Maclaurin's expansion and there I would be able to explain that to you. But somehow, right now, let's focus on what the formula is and how we use this particular formula and why is this formula useful. So this is 1 plus x to the power n, and this expands to 1 plus nx plus n minus 1 over 2 factorial times x square. And obviously, it just keeps on increasing with the powers of x. Now, there are a couple of things. First of all, of course, one may say that if this is an infinite series, then how is it useful? Because I would only be able to find few terms in this expansion. So this is only valid for situations where absolute value of x is less than 1. Which means, like, for example, if you have x, which is 0.2, its absolute value is less than 1, then you would know that as you will keep on erasing higher powers of it, it will keep on becoming smaller and smaller. For instance, 0.2 to the power 2 would be equal to 0.04. That's a smaller value. Or 0.2 to the power 3 is going to be 0.008. So with every increasing power, the value keeps on becoming smaller and smaller, which is why this gives us a very good approximation or estimation, because higher powers of x will give us smaller values and they can be rejected or ignored, which is why this expansion is only valid for absolute value of x is less than 1. So whenever you are given any particular expansion to expand with negative or fraction power, you have to compare it with this form, identify what is in place of x, identify what is in place of n, and substitute those over here and do your expansion. But yes, you have to understand, first of all, that there has to be 1 over here. Like, for example, if there's a particular situation where you have to expand 2 plus x to the power, let's say 1 upon 4. So you would not be able to do expansion over here because there is a 2 over here, which means that the first thing that you should be doing over here is that you should take 2 common. So if you take 2 common, inside you would be left with 1 plus x upon 2, and that is equal to 1 over 4. Since you have taken 2 common from inside, so this will also get a power of 1 over 4 with it. And then you will do an expansion of this thing by comparing this with this and identifying x is equal to x by 2 and n is equal to 1 over 4. The other thing that you should always be able to do is to sort of recognize the fact that this expansion is valid. This expansion is valid for absolute x less than 1. Hence, this expansion should be valid for absolute x by 2 to be less than 1. And you can further simplify it. You can remove the modulus sign and you can say plus minus x by 2 should be less than 1, or x should be greater than negative 2 and less than 2. So you can find out the range of values of x as well for which the expansion is valid. By the way, we will have another video regarding modulus inequalities. But for now, I can just tell you that whenever you are solving a modulus inequality and you remove the modulus sign, the side from which you remove the modulus sign, you will introduce a plus and a minus sign over there. And which is why I wrote a plus and a minus sign so that I can get two separate ranges. And then after identifying that this is how it's going to look like, you just need to compare this, like 2 power 1 over 4 would stay where it is. And then you will start expanding it by using this formula and writing n as 1 over 4 and x as x by 2. So you can see I can start writing down the terms, which is going to be 1 plus 1 over 4 x by 2, that's my second term, plus 1 by 4 times 1 by 4 minus 1, and then x by 2 to the power whole square divided by 2 factorial. Or if I want to find out the next term, that's going to be 1 by 4 minus 1, 1 by 4 minus 2, x cube, in this case is going to be x by 2 whole cube, and whole divided by 3 factorial, and so on and so forth. So you can, examiner will tell you that till how many terms examiner wants you to do this expansion, and you will continue on till that particular point. But this series obviously continues on and on. The rest is simplification. We will see about that simplification. Let's do some example questions. Like for example, I have this question where I have to expand 1 minus x power 2 in the denominator. So again, before I start off in my expansion, I'm going to have to make sure that it becomes comparable to the formula, which means that this goes in the numerator. It becomes 1 minus x to the power minus 2. So I can see that x, in this case, if I would compare this with the formula of 1 plus x to the power n, then I'd be able to say that x basically is minus x in this case, and n is equal to minus 2 in this case. So therefore, I can start expanding it, and I can say 1 plus nx, that's going to be minus 2 times minus x, plus n, which is minus 2, n minus 1, which will be minus 3, x squared, that will be minus x whole square divided by 2 factorial, plus n, which is minus 2, n minus 1, which is minus 3, n minus 2, which would be minus 4, minus x whole cube divided by 3 factorial. So this is my expansion of the series. The question asked me to do it till x cube, so I will just do it till x cube. I can just sort of do this representation to indicate that the series still continues on. So this will be simplified as 1 plus 2x. Minus and minus becomes plus, so this also becomes plus. 2 cancels, 3x squared, and this is minus, 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 so this also becomes plus, and 3 factorial cancels, because 3 factorial is 3 times 2, so that cancels with 3 and 2, so that is going to be 4x cubed, and this is going to be my expansion of this particular series. Let's have a look at another example over here where I have to expand 1 plus 2x to the power 5 upon 2. It's so important that right in the beginning I'm able to recognize that x in my formula that's going to be given to me in the formula sheet is x is 2x over here, and n in the formula is 5 over 2. The rest is just formula putting. So what I'm going to do is that I'm going to write down this is 1 plus nx, that's going to be 5 by 2 times 2x, plus n 5 by 2, n minus 1, 3 by 2, x squared, that'll be 2x squared divided by 2 factorial. Again, I have to do this expansion till x cube, so I will also find out the next term, which is going to be 5 by 2, 3 by 2, and then again subtract 1, so this is going to become 1 by 2, 2x to the power 3 whole divided by 3 factorial. And then I'll do my simplification. This one being copied as it is, 5 by 2x and 2x, the 2 will cancel out. So this will simplify as 5x, this 2 and those 2 would cancel out. Similarly, this 2 and this 2 will cancel with the square of 2 over here. So this is going to be plus 15 upon 2 x square. Likewise, this 2, and this 2 will cancel out with this 2 cube. And the next term would be 15 divided by the 3 factorial. 3 factorial would be equal to 6 x cube. And then you can simplify this furthermore. 3 times 5 is 15 and 3 times 2 is 6. So this is your expansion here. Let's have a look at another example where you have to expand 8 plus 3x whole power 1 upon 3. Now, you have to do a bit of an extra working over here, which is because of the fact that the first term you have to make sure is 1 always whenever you do your expansion. So if it is not equal to 1, then you have to take the constant out common so that it becomes 1. So I take 8 common out here so that the first term becomes 1 and the second term becomes 3 by 8x. But do not forget that since you took 8 common out from inside the bracket, so this will also have a power 1 upon 3. 8 power 1 upon 3 simplifies to 2, which you can simplify later on alongside. But then look at the expansion. For this expansion, your x of the formula is basically 3 by 8x. And your n of the formula is basically 1 upon 3. So you apply the formula 1 plus nx. N would be 1 upon 3 and x would be 3 upon 8x. Plus n, which is 1 upon 3, n minus 1, which would be 1 upon 3 minus 1, 3 upon 8x whole square divided by 2 factorial. Then you write down the next term, and that's going to be 1 by 3 minus 2 by 3 minus 2 by 3 minus 1, 3 by 8x whole cube divided by 3 factorial. And do not forget that all of these terms are getting multiplied by 2 later on. I will do 2 times 1 plus this 3 and this 3 cancels out over here. So this is going to become 1 upon 8x. And then this is going to be 1 upon 3 and minus 2 upon 3 times 3 square upon 8 square divided by 2 x square plus 1 upon 3 minus 2 upon 3 minus 5 upon 3 3 cube divided by 8 cube x cube divided by 3 factorial, which is 3 times 2, and that would be equal to 6. I continue on over here. This is going to become 2 times 1 plus 1 over 8x. This 3 square cancels with this 3 and this 3. This 2 cancels with this 2. So this is going to become 1 upon 64 with the minus sign. This becomes 1 over 64 with a minus sign x square. And then I will simplify all of these terms. So this is going to be 3 cube cancelling with this 3, and this 3. A minus and a minus is going to become plus. And this will be 10 divided by 8 cube times 6 and whole multiplied by x cube. So if you would simplify this, you multiply all of this by 2. The first term becomes 2. The second term, 2 times 1 over 8 would simplify as 1 over 4x. And then 2 times minus 1 over 64 becomes minus 1 over 32x square. And then you simplify the term next as well. So this is going to be multiplied by 2 as well. And when you simplify 2 times 10 divided by 8 cubes times 6, that simplifies as 5 over 768x cubed. And this is going to be your expansion. By the way, this question also asks one more thing. It's not double F. State the values of x for which the expansion is valid. So what you're going to do is not look at this one, but look at this one, and you will say that 3 by 8x, the modulus of 3 by 8x should be less than 1. Or once you remove the modulus, this simplifies as x is greater than negative 8 by 3 and less than 8 by 3. So you get yourself a range of values of x as well for which the expansion is valid. Now, let's have a look at the past paper type questions. Like you get a question like this where it first says express this in partial fraction. In my previous video, I have covered in detail how to express a fraction in terms of its partial fraction. So I'm assuming that we know how to find out partial fractions, and we have already found out the partial fractions of these. And we move on to the next part where it says when x is sufficiently small, we have to show, with higher powers being neglected, we have to show that this function simplifies to this function. So if you look at what you have over here, or maybe this particular form, and you look at this form, then you obviously would get a hint over here that you have to simplify this by using binomial expansion. So I start off with assuming, I'm doing part 2 over here only, and I start off with assuming that I have the partial fractions already. So I start off with 4 upon 2 minus x plus 4x plus 1 upon 1 plus x squared. And then I will obviously have to shift it up to the numerator. So this is going to become 4 times 2 minus x to the power minus 1 plus 4x plus 1 times 1 plus x squared also raised to the power minus 1. I have to do the binomial expansions of this term and this term, but I'm not ready to do the binomial expansion of this term because its first term is 2 and I want it to be 1. So what I'm going to do is that I'm going to take 2 power minus 1 common. So this becomes 1 minus x upon 2 to the power minus 1 plus 4x plus 1 and 1 plus x squared to the power minus 1. Now I continue on with this. The first coefficient is going to become 4 upon 2. That simplifies as 2. I will do an expansion of 1 minus x by 2. So this becomes 1 plus nx, that will be minus 1 times minus x upon 2, plus n minus 1 minus 2, x squared, that's minus x by 2 whole square, divided by 2 factorial. And since I need it till x cubed, so I'm going to write down the next term as well, which is going to be minus 1 minus 2 minus 3 times minus x by 2 whole cube divided by 3 factorial. I don't have enough space here, so I will continue writing down the next part of the series in the next line. So basically this is equal to this is equal to this, and this is equal to this. So I have to add this series as well, which will be 4x plus 1. And then I'm going to expand 1 plus x squared. So that's going to be 1 plus nx, that is going to be minus 1 times x squared. Now, the other thing is that if you would continue on with the expansion, you know that this is going to be squared, and square of square would become 4, a term that I do not need. So I can stop the expansion over here. If I expand it furthermore, then I'll get the terms which I'll have to ignore eventually in the end. So I may stop it here and then start off with the simplification process. So this is going to become 2 times 1 plus x upon 2 plus, because this minus and minus becomes plus, and minus square also becomes plus. And I will have 2 and 2 cancelling out. So this is only simplifying as 1 upon 4 x squared. Similarly, this 3 factorial will cancel with this 2 and this 3 because 3 factorial is 3 times 2. Minus, 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 and another minus becomes plus. And I will be left with 1 over 8 x cube. Now this is the expansion of the first part of the series, and then I have 4x plus 1 being multiplied by 1 minus x squared. I have to continue on with the simplification. 2 times 1 is 2, 2 times x by 2 is x, 2 times 1 by 4 is going to be 1 by 2 x squared plus 1 by 4 x cubed. And here I have to multiply these two products. So 4x times 1 becomes 4x. 4x times minus x squared becomes minus 4x cubed. 1 times 1 becomes 1. And 1 times minus x squared becomes minus x squared. Now I have to simplify all the terms together. So 2 and 1 will add up to 3. X and 4x would add up to 5x. And then half x squared and minus x squared would simplify to minus half x squared. And I have two terms of x cubed as well. So minus 16 plus 1 is minus 15 by 4 x cubed. So this is my expansion, and this is what I had to prove, which exactly matches with that. So this is basically how I would do my binomial expansion. So most of the questions that you will expect in exam would be first part doing the partial fraction, and next part using those partial fractions to simplify a series. Guys, let's have a look at another example from the past papers, where in first part of the question it says simplify this, showing your working. Let's first focus on this part of the question. So if I have to simplify this, I mean, I can do it by the longer way. I can see that this is multiplying by this, so I have to multiply each term one by one. But I can also have a shorter way of doing it if I could recognize that this is same as this and this is also same as this. So if I suppose it as A and I suppose it as B, so this is basically the product of A plus B and A minus B. And I do know that the product of A plus B and A minus B is equal to A squared minus B squared. This is why I'm getting less marks over here, so that I can recognize and do it quite readily this way. So if I'm going to do it by A plus B times A minus B, so this is going to become under root of 1 plus x whole square, that's A square, minus under root of 1 minus x whole square, that's B square. And once I do that, you know that square and square root will cancel, so this is going to become 1 plus x minus 1 minus x. This will become 1 plus x minus 1 plus x, and that simplifies to 2x. I've got myself a simplification of this, and that basically sort of tells me that 1 plus x under root plus under root 1 minus x times under root 1 plus x minus under root 1 minus x is equal to 2x. That is something that I've just deduced, I've just proven. Now it says you have to use this working to deduce that this is equal to this. Now if I form this, this is something I should be able to figure out quite easily, that if I shift this 2x on the left hand side and if I shift this term on the right hand side, I would be able to deduce it. So just cross multiplying and I will get myself under root 1 plus x minus under root 1 minus x divided by 2x. So I have retained this on the same side, I've cross multiplied 2x on the other side, and then I will cross multiply this on the right hand side. So this is going to become equal to 1 upon under root 1 plus x plus under root 1 minus x. Now this was basically a simple algebraic simplification or may I say it was a little complicated one, but somehow once I've gotten this simplification, I have to use this to obtain the expansion of this particular thing. So using this result, so obviously, I mean, sometimes you have these difficult kind of questions where you have to sort of recognize that you have to use previous working. If you will think of trying to attempt this question in isolation, you would be a little stuck. But somehow, if you would be able to recognize that, yes, sir, this is equal to this. So what I can do is to expand this, I have an option of simplifying this. Inside, I will rewrite 1 over 2x separately. This is going to become 1 plus x to the power half minus 1 minus x to the power half. Although I have to expand it till the term in x square, but I can see an x in the denominator, which means that I have to do my overall simplification till the term in x cube, because x cube divided by x would simplify as x square. So I will start doing the expansion over here. 1 over 2x would be written down as it is. I'll do the first expansion, 1 plus nx, that's going to be half times x, plus n, that's going to be half, n minus 1, that's going to be minus half, x square divided by 2 factorial, plus n, that's half, n minus 1, that's minus half, and n minus 2, that's going to be minus 3 by 2. X cube divided by 3 factorial. Now, similarly, I have to do the expansion for the next part of the series as well. I'm a little short of space, so I'm writing down the expansion of the next series in the next line. So minus, brackets open, 1 plus nx, that's going to be half times minus x. X in this case is going to be minus x, plus n, that's half, n minus 1, that's minus half, x squared, that's going to be minus x whole square divided by 2 factorial, plus n, that's going to be half, n minus 1 minus half, n minus 2 minus 3 upon 2 minus x whole cube divided by 3 factorial. Now, once I am able to do this, and don't forget that all of this, the entire thing is getting divided by 2x after I do my simplification. So this is 1 over 2x. Now let's start simplifying it. This is going to be 1 plus half x minus 1 over 8x square. That's because 2 times 2 becomes 4, 4 times 2 becomes 8. Then I'll move on to the next term. That's going to be the 3 factorial gets opened as 3 times 2, and this 3 cancels with this 3. So 2 times 2 times 2 times 2. So that's going to be 16. So this is going to become plus 1 upon 16 x cube. I'll continue on with the simplification. So this is going to be 1 minus half x minus 1 over 8x square, and then minus 1 over 16x cube. Now when I simplify this, 1 cancels with 1, half and half would add up, minus 1 over 8 cancels with plus 1 over 8, plus 1 over 16, and plus 1 over 16 are going to be added up. So this is going to become 1 over 2x, half x plus half x becomes x, and plus 1 over 16, and 1 over 16 becomes 2 over 16x cube. And when I multiply both of these terms with 1 over 2x, the first term simplifies as 1 over 2, and the second term simplifies as 1 over 16x square, which is our required answer. So this is, guys, how you use your binomial expansion for an infinite series where the powers of x will keep on increasing, and this is applied to situations where your binomial has a non positive integer power. So the power could be negative and the power could also be in terms of fractions. That's it from my side. Thank you guys. Hope you liked the video, and please do subscribe to my channel, give a thumbs up and share it with your friends if you found this a learning experience. Thank you.